सर सुरू करायचं. झाडे सर सुरू करायचं.
Yes, I'm ready. On time.
स्वागतम सुस्वागतम सुस्वागतम. Good afternoon, everyone. I, Dr. K.B. Raulkar, convener of this webinar. At the outset, I extend my hearty welcome to all. Honorable President Sri Ravsaheb Shekhawat sir, Honorable Mrs. Manjiri Shekhawat Madam, President of James Vidya Bharati Mahavidyalaya Amravati, Honorable Secretary Dr. A.D. Chavan sir, Honorable Principal Dr. P.S. Yankar Madam, respected Dr. I.M. Patil sir, IPSC and NAC coordinator of this college, Professor M.M. Rathod Madam, coordinator of research cell, and all participants. Today we have gathered here for one-day webinar on recent trends in nanosciences. It is known to all of us that the decades of research and development in nanoscience and technology have delivered both expected and unexpected benefits of our society. Nanotechnology is helping to improve products across a range of areas, including food safety, medicine and healthcare, energy, transportation, communications, environmental protection and manufacturing. It is being used in the automotive, electronics and computing industries and in the household products such as textiles, cosmetics, and list is very high. आवाज येतोय का? आवाज येतोय? Hence, the ability to tailor the core structure of material, ability to tailor the core structure of materials at the nanoscale to achieve specific properties is at the heart of nanotechnology. So, nanomaterials are very useful to our society in daily life. Hence, in order to enlighten the subject in detail, we have two eminent speakers for this webinar, Professor Ramesh Jhade sir, Associate Professor, Department of Physics, Department of Chemistry, Siddharth College of Arts, Science and Commerce, Mumbai, and Professor Kushal M. Ude, Sir, Department of Physics, Bhavans College, Andheri West, Mumbai. I heartily welcome you, sir. Now, I invite Honorable HOD Professor Dr. T.S. Vasnik sir to welcome the speaker and inaugurate the webinar. Sir, please.
Good afternoon, Jhade sir. And good afternoon.
Very good afternoon. Very good afternoon, sir.
Nice to see you, sir. Nice to see you.
Thank you, sir.
Good afternoon, one and all. Welcome to this online webinar. At the outset, I extend my hearty welcome to Honorable President Dr. Rao Sahib Shekhawat, President of Vidya Bharati Shaikshanik Mandal, Honorable Mrs. Manjurita Shekhawat, Chairman of James Vidya Bharati Mahavidyalaya Amravati, Honorable Dr. A.D. Chauhan, Secretary, Vidya Bharati Shaikshanik Mandal Amravati, Honorable Principal Dr. P.S. Enkar, Vidya Bharati Mahavidyalaya Amravati, eminent speaker for today's webinar, Mr. Kushal M. Mule, Associate Professor, Department of Physics, Bhavans College, Andheri West, Mumbai, and Mr. Ramesh Jhale, Associate Professor, Department of Chemistry, Siddhartha College of Arts, Science and Commerce, Fort Mumbai. Dr. R.M. Patil, NAC and IQC Coordinator, Vidya Bharati Mahavidyalaya Amravati, Professor M.M. Rathore, Research Cell Coordinator, distinguished invitees, teaching and non-teaching staff of the college, and the below students of the college to this online webinar on recent trends in nanosciences. Ladies and gentlemen, and all my dear students, it is indeed a matter of immense pride for me to be here today to welcome you all to a very special and momentous occasion of the Department of Physics, Vidya Bharati Mahavidyalaya Amravati. Today we have the unique honor and privilege of listening to the two eminent speakers, Professor Ramesh N. Jhale and Professor Kushal M. Mule, who will speak on nanomaterial behavior and its application in the today's one-day webinar on recent trends in nanosciences. I sincerely welcome you, sirs, on behalf of the Department of Physics, Vidya Bharati Mahavidyalaya Amravati. Now, it is time to announce that today's webinar is inaugurated. I express my sincere gratitude and gratefulness to you, sirs, for having joined here to guide and enlighten us. Sirs, your lectures will be very fruitful to us. Thank you very much. I hand over the mic to Dr. A.O. Chauhan for further activities. Chauhan, sir, please.
Thank you, sir. Good afternoon and all. I, Dr. A.O. Chauhan. At the outset, I extend my hearty welcome to all in today's one-day webinar on recent trend in nanosciences. Here, I am here to tell you about the Department of Physics with the Mahavidyalaya Amravati. The Physics undergraduate department came into existence in 1930 and in 1993. Since the beginning, the students of this department have been performing exceedingly well in academics as well as co-curricular activities. Within the last 5 decades of its meaningful existence, 35 postgraduate students have appeared in the university merit list, and our students have produced commendable performance at university level seminars and quiz competitions. We are similarly fortunate in being blessed with highly inspiring and visionary leadership of Honorable Dr. Devi Singh Ji Shekhawat sir, founder of Vidya Bharati Shaikshanik Mandal Amravati, Her Excellency Honorable ex-President of India, Srimati Pratibha Sai Patil Shekhawat Madam, Honorable Rao Sahib Shekhawat sir, President of Vidya Bharati Shaikshanik Mandal Amravati, Honorable Mrs. Manjurita Madam, Chairman of James Vidya Bharati Amravati, Dr. P.S. Enkar Madam, Principal of VBMV Amravati, Dr. R.M. Patil Sir, IQAC and NAC Coordinator of Vidyarthi Mahavidyalaya Amravati, Professor M.M. Rathod Madam, Coordinator of Research Cell, and Dr. P.S. Vasnik Sir, Head of Department of Physics, Vidyarthi Mahavidyalaya Amravati. The best possible infrastructure, laboratory facility, and academic ambience have been the major strength of the department. The success of the department is the result of the commitment and integrity of the staff and hard work of the students of the department. We are very happy and proud that our Honorable Principal, Dr. P.S. Enkar Ma'am, is a woman of many honors and distinctions. We feel extremely proud to mention that all of our teachers have actively engaged in a quality research work. Their findings have been published and presented in prestigious national and international journals and conferences. Leading by an example, Dr. R.V. Jose Sir had participated in international conference held at Singapore. Besides this, our teachers, namely Dr. T.S. Vasik Sir, Dr. R.V. Jose Sir, Dr. G.T. Lamdade Sir, Dr. K.B. Raudkar Sir have minor research projects in their credits. We are happy to let you know that Dr. G.T. Lamdade Sir has been sanctioned and completed a collaborative research project by UGC DAE for scientific research Indore. Up till now, we have 12 research projects funded by UGC and more than 160 research papers have published in reputed and reviewed journals, and more than 100 conferences have been attended by the faculty members. Up till now, 28 research scholars have been awarded PhD degrees and 12 students are working for their PhD research, and more than 50 students have qualified in either NET or STATE or GATE examination. Recently, Mr. Rohit Butle, Mr. Bhushan Bhati, Mr. Akshay Bodulwar, Kumari Anjali Atram passed STATE examination, and Mr. Prathamesh Nikam of BSc final year has been awarded with Nation Budding Innovator Award in 2019. We have arranged many of programs under the Physics Society. Our faculty members actively participate in administrative as well as other extension activities, which mainly includes NCC, NSS, and the works related to NAC, UGC, Alumni Association, and makes charity contribution to need students as well as social organizations such as the Poan Vruddhashram and Help Age India. With your blessings and the best wishes, we hope to achieve many more milestones in the future. Thanking you.
Thank you, Professor Vasnik sir and A.O. Chauhan sir. Now, Jhade sir and Kushal Mude sir. These are my friends. तो उनके लिए मैं एक सेंटेंस बोलना चाहूंगा. झाड़े सर, प्लीज.
यस सर, यस सर.
Sirs, मतलब झाड़े सर एंड कुशल सर दोनों के लिए. Sirs, you are beautiful. You look wonderful. This webinar is houseful because you are very powerful. Because you are very powerful. Now I request Professor Ramesh and Jhade sir to deliver lecture on behavior of nanomaterials. Sir, please.
Thank you, Raulkar sir. First of all, I would like to thank the management of Vidyarthi Mahavidyalaya Amravati, President Shekhawat sir, Madam Shekhawat sir, then Secretary sir, Principal Yankar Madam, who has taken entire effort in arranging this national seminar. I am also very much thankful to Dr. R.M. Patil sir, who is IQAC and NAC coordinator, I'm also very much thankful to Professor Rathore sir, who is research cell coordinator. Just I was going through the entire introduction of the college and the legacy which college is carrying, and looking forward into the more and more areas, okay, and so as to make the entire all-rounder development of the college and the students and teacher as well. I'm also very much thankful to Dr. Vasnik sir, who is very much respectful for me. I'm also thankful very much to Lamdade sir, Dr. Chavan sir, and my very friend, Dr. Kishore Raulkar sir. And I'm also very much thankful for my all teacher participants and my beloved dear students. The very relevant topic has been chosen by the entire organizing committee and the mentor, Dr. Yankar Madam, for this particular purpose. And the topic itself is very relevant, as has been told by Rahul Sir and Chavan sir in the introduction. Now, I have been given a kind of a job, okay, which is basically covering the fundamentals behind this nanoscience and nanotechnology. That is how this behavior of nanoparticle. Okay, so I'm going to start my presentation.
Yes, sir.
Sure, sir. Just let me know whether my screen is visible to all or not.
Belong the screen. Yes, sir, sir.
Okay.
Yes, sir. Screen is there, sir.
Okay. Thank you very much, sir. Okay. So my topic of today's lecture, that is behaviors of nanomaterial. This is very much important, though it is fundamental, but with the advancement of nanoscience and nanotechnology in the near future, this behavior of nanoparticle is not truly exploited till date. Okay, we are having certain fundamental on the basis of which we have reached some goals of the nanoscience and technology, but still there are some aspects in the fundamentals of nanotechnology itself, nanoscience itself, which are yet to be discovered and confirmed. And that is the reason there is a lot of scope in this particular field of fundamentals of nanoscience, which is specially dedicated to behaviors of nanomaterial. And I am going to talk on this. Now, everybody, so before the start of my lecture in true sense, I'm going to, okay, I would like to pay my regards to the person because of whom we are here, because though he was a physicist, but I think so everybody is aware about the person whom I'm talking about. Okay, he's Richard Feynman, okay, very handsome, nice looking guys, and who was a Nobel laureate, okay, who received Nobel Prize in 1965. Okay, 6 years after his famous lecture at American Physical Society at Caltech. In December 29, 1959, he has given a very wonderful and very prospective lecture, which actually takes the contemporary scientists, researchers, and students into a very different gamut of science and technology, very after the quantum mechanics. So we can consider the advancement or the emergence of this nanoscience and technology is a breakthrough after quantum mechanics. Okay, earlier the classical mechanics was propagating like anything up till 19th century, but at the outset of 20th century, we all of you know that quantum mechanics has emerged after Max Planck, Einstein, and there were many scientists who were responsible for this entire development of quantum mechanics. So everybody thought that now this is a new science and everybody will follow that. But this Richard Feynman, okay, has given a little more dimension into that. And what nanoscience and technology today is developing, it is because of the ideas, the principles, a hypothesis which was given way back, okay, nearly you can say 70 years ago by Richard Feynman, and he's rightly said that there is plenty of room at the bottom. Now, this very little sentence of consisting of 7 words has a lot of things into that, which takes us to think about how really we can do research, how we can develop a different kind of philosophy into the science and technology. So thank you very much, Feynman sir. Okay, I should be thankful because I am chemist, and okay, I am owing my rewards to physicist Richard Feynman. Now, why we should look and study the science and nanoscience and technology? Because we are very much concerned with the applications of nanoscience and technology, and just look at this particular table, which will tell you that how widely this nanoscience and technology has spread, and it reaches and touches each and every field: engineering, energy, medicine, electronics. Okay, in engineering, the students are doing, researchers are doing nanocomposites, they are doing sensor, they are self-cleaning glasses, membrane filters. In energy science, because nowadays world is facing energy crisis, so even India is facing the problem, and so the science and technology can rightly can give away the solution in the form of thermal conversion, solar cells, batteries, and catalysts. Then in the field of medical science, okay, there are many things which are come out of this nanoscience, like orthopedic implants, nano drugs, nano delivery also of the medicines, then molecular engines, which I'm just that is drug delivery systems. Then in case of diagnostic also, and of course electronics I should not tell, because all the very student and teachers of physics are sitting here, so I will not go into details of what is there in electronics. Now the very question of that, what to call nanomaterial, how it looks, how small it is, and it is not simply that we are having a nanometer. Everybody knows that it is 10⁻⁹ meter. Okay, it is not only the one kind of dimension, okay, which we learn in physics or mathematics, but it is something which is little bigger than atom, but at the same time it is smaller than what we call micrometer. Micrometer means 10⁻⁶. So here you can see it is the size which is between 1 to 100 nanometer. So I can say that 1 nanometer is 10⁻⁹ meter, or 100 nanometer is something 10⁻⁷ meter. So this is something size, okay, which is between micrometer to, okay, you can say angstrom. Now what makes this dimension very, very different, because the behavioral property or the change in the properties of nanoparticle is based on this dimension scale. So here, to which particle we can call the nanomaterial? Basically, okay, there are a lot of definition, but the most accepted definition is that we know that particle will have dimension, either it is 1-dimensional, 2-dimensional, 3-dimensional, or it is 0-dimensional as well. And any one dimension of that particular particle, if it is measuring between 1 to 100 nanometer, then you can call it as nanoparticle. Okay. Now, as I told in the beginning, it is not in the size only everything. It is basically the change in properties. So you will find that there are properties which are abruptly changing from macro science to nanoscale, and that's why this particular scale is very, very important. Now, there are many examples of nanoparticles, like silver nanoparticles, then buckyball. Buckyball is basically made up of carbon, okay, which is a kind of saucer ball. Okay, so carbon will take the form of saucer ball. And then there are kind of rod-like particles, nanotube, tube-like particles. Okay, we will going to see what are carbon nanotubes, and then TiO2, titanium dioxide nanotubes. So correlation between the size of the particle and the wide area where the nature has exhibited this dimension. Okay, we are just talking about science and technology, but truly the nature is also displaying this particular nanoparticles in entire the beauty of nature. And we know the color of flowers, then the lotus leaf. Okay, lotus leaf is very specially known that the moment you put water on that, water assumes a different kind of shape, means it's spherical shape. Now why it happens with lotus, why not others? So again, the reason behind that, it is the surface of lotus which actually makes the difference. And here, okay, you can see I am very much interested in this particular area. Okay, in this particular area, okay, which is between this angstrom and this micrometer. And you can find in between these, you are having a 0-dimension particle, 1-dimensional particle, 2-dimensional, and 3-dimensional. Okay, so this is our nature is full of this nanoscience or nanoparticle actually. Basically, we are trying to mimic those techniques of nature, how nature must have been produced. Okay, being producing these nanoparticles in the nature, and it gives giving you the vivid nature to entire you can say globe. So we are going to mimic that in the form of intended study or intended research. Now here you can look the wide arrow of these nanoparticles. It starts from the 1-dimensional platelets like Montmorillonite clays. These are basically clays which made up of silica and other material. Then these are nanographene platelets. Then layered double hydroxy, LDH is known. Okay, so carbon nanofibers. Okay, you can just go through these. You will find the different dimension. Platelets is one-dimensional because it is having nanoscale dimension in one of the dimension. Then these are fibers. Okay, lengthwise it may be very high, but other dimensions are in the nanoscale. That's why it is 2 nanoscale dimension. And then particulate matter, which is everywhere in all the 3-dimensional, it is having nanoscale. And here you can see the list of these nanoparticles: phos, nanosilica, nanoalumina, silver, titanium, nanomagnesium. Of course, here the gold I have not taken. I am going to take that little later. Now, this is the crux of entire presentation, you can say. Okay, here we have to think a little philosophical. Okay, why nanoparticles have different properties than bulk particles or bulk matter? So basically, it is the surface effect, or in short, you can remember, I'm going to take this in little detail. The surface effects means the surface of this nano material is having a different perspective than the matter which is present in the bulk. So in one short way, you can say it is having lower coordination. That means the number of coordination around that particular material is low because it is having coordination from the bulk matter itself, whereas the surface from other side, or you can say the boundary of the phase is open, and that's why it is not having coordination from that angle. So from lower side, or you can say from the bulk side, it is having coordination, but other side it is not having coordination, or you can say bonds, or you can say valencies. Now, what is the effect of this surface change? It greatly affects the melting points. Actually, it reduces the melting point. We will see how it is. Then, there is phase transition temperatures. We know that whenever we are changing, simple, you are taking ice, it's one phase. When we are changing into liquid, there is water, it happens at particular temperature. But if you are converting the same thing into a nanoscale, then that particular transition temperature may not be 0 degrees Celsius, it may be something different. And in physics, we do study critical points, critical temperature, critical volume, critical pressures. And okay, by using this nanoparticle or nano dimension, we can also able to change critical points. Okay, changing critical point gives us a different way to do the science and technology, do the experiments, okay, in a very simple way, because critical temperatures are extreme temperatures, some things. Critical pressures are also extreme pressures. So maintaining this extreme temperature and pressure is sometimes very difficult. So we have to bring down these critical conditions. And yes, nanotechnology is helping you out in bringing down these critical points. And very important, it doesn't obey the Gibbs phase rule. Okay, you might have studied in chemistry. Gibbs phase rule is equal to, it is F is equal to C minus P plus 2. Okay, where F is degrees of freedom. Okay, and C is component and P is number of phases. Gibbs phase rule is widely used for studying thermodynamics, then electrochemistry and material science as well. Okay, but it is valid up to macro scale, micro scale, like 10 raised to the power minus 6. But as you are exceeding 10 raised to the power minus 6 and going into the lower scale, this Gibbs phase rule is not applicable. Okay, so this is something we can say that the rules which are applicable to microscience or macro matters are not applicable. Okay, so this is the first instance you can say where the Gibbs phase rule is not obeyed by nanoparticles. Secondly, the typical smoothly scaling properties due to surface effect. Okay, that means we know that if you're cutting down a particular matter into smaller and smaller size, okay, we are getting different properties. Okay, say for example, you are taking surface area, then after cutting down the particles into smaller and smaller, the surface area is increasing enormously. Okay, because surface area is having a 2 dimension. So if you are, say for example, you are cutting down into 10 particles, then suddenly the surface area increases by 100 times. Okay, so that is how, okay, so suppose surface area increases by 100 times by cutting down one particle into 10, then these properties, say for example, okay, melting point, okay, that also follows the same trend. Okay, so there is significant change in the properties. So that's why it is obeying scaling law. Scaling law means cutting down the particle into smaller and smaller, and we are correlating this particularly with the change in the physical property. That is what scaling law. Then breaking down of thermodynamics. Okay, this is another breakthrough which is brought by nanoscience and technology, that the rules of thermodynamics are not being followed. Okay, rather the thermodynamics of nanoscience is not obeying the laws which are given by we know the 4 laws of thermodynamics. Okay, so the thermodynamics also does not apply to this nanoscience and technology. And the very important that, okay, the physics student might be very interested in this particular thing, quantum confinement effects with delocalized electron state. Okay, in short, you can understand the properties which are size dependent. Okay, size, I mean to say the size of nanoparticle, actually if you look into the nanoparticles inside of the nanoparticle, it is not only one atom or one molecule is present, it is the aggregation of some atoms or some molecules. Okay, now that will take this atomic size or angstrom size into nanoscale. Now, but we cannot keep on adding atoms or molecules into that. We have to restrict the number of atoms or molecules which are following a single cluster. Okay, so here you can just look at this term, okay, delocalized clusters. So basically, delocalized cluster means these are the aggregation of atom or molecules in the nanoscale dimension, which are having different behavior than the microscale matter. So here this quantum confinement is basically related. Just I'm taking an example of an atom. Suppose you are having atom, the electron up to which electron up to the area up to which electron is spread around an atom is having a certain confinement. Okay, you can say the last electron up to which the area up to which the electron can extend, okay, will have 0 energy. Okay, So that is the confinement of an atom. Similarly, the cluster, which is a nanoparticle cluster, is also having this kind of confinement up to which their electron are spread. Here, because of this cluster, okay, it gives a new concept of pseudo atoms. Okay, just now we have seen that these are not actually atoms; these are the aggregation of atoms or molecules, but it is having behavior which is between atom or molecule and microscale particle. Okay, so you can say that nanoparticles are having intermediate behavior between the atoms and molecules and microscale particles. Okay, so that's why we can call these nanoparticles as pseudo atoms. Now, how it brings the property change? Okay, absorption and fluorescence valence become okay size dependent. We are going to see this particular thing okay vividly with using some pictures. Then non-magnetic elements are also going magnetic. Okay, now I rightly remember that magnetism or supermagnetism was a buzzword in the decades of 80s and 90s. Every researcher or scientist, especially physicist or material scientist, were okay running after the super magnets, or okay you can say magnets. Okay, because we know that we cannot easily create the magnet at ambient temperature. But here, because of these nanoparticles, we can have a magnetic behavior even at room temperature. So the material which was non-magnetic earlier can become magnetic if you bring down the size to nanoscale. Then my pet subject, that is catalysis. Okay, catalysis, which is basically we know everybody that catalysis play very important role in carrying out the reactions. Okay, chemical reactions normally okay do not take place on its own sometimes, and it requires catalyst. Catalyst is that kind of material which is not the part of reactant, but yes, it increases the rate of reaction significantly. And this catalyst are nowadays prepared in the nanoscale because catalyst, the first condition of catalyst, that it should provide more and more surface area, which is quite possible if you prepare catalyst in the nanoscale. And what effect it brings in catalytic activity? Basically, selectivity. Okay, activity means increasing the rate of reaction, and selectivity means okay it gives you particular product in more amount. Okay, we usually see in a reaction that if you starting with two reactant and we are expecting only one product, it happens that there are 3-4 products, and separating those product from the desirable one is really a headache kind of thing. That's why we always expect that you should get only single product. Okay, that will be pure product. But what happened, as I told you, okay, it may give 3-4 product. But if you are using a catalyst which can give a selective product, okay, that means you can confine your products only to one desired product, and that will really decrease down your job to separate the different products and all that. Okay, and this is very wonderful thing about catalyst. And lastly, okay, this is a little bit of chemistry. Ionization potential and electron affinities. These are very fundamental properties of an atom. But even these are applicable to nanoscale material. Okay, actually these are the property of atom. Okay, but with the advancement, as I told you, that you can consider these nanoparticles as pseudo atoms. You can apply these properties, ionization potential and electron affinity, even to nanoparticles. So you can tune the ionization potential and electron affinity by bringing down a material into nanoscale. So now we are considering property one by one. Okay, this is melting point. Okay, you know this melting point is a very important criteria for material to be pure, and moreover to handle the material, or to, you can say, okay, to check the viability of the material at extreme temperatures or lower temperatures. So here this nanomaterial, okay, is found to lower the melting point significantly. Okay, now the question that how this melting point is reduced. So it is seen that it is because of okay, huge fraction of surface atoms. Okay, the very importance of that nanoparticles is that it increases surface area. That means more and more number of atoms are coming from bulk to surface. So the number of atoms present on the surface are more as compared to the number of atoms or molecules present inside the bulk. And because of this, the surface energy of that material increases significantly. Okay, and now this melting point is a kind of physical properties which is depend on interatomic or intermolecular attraction, and this because of increase in the surface energy of this nanoparticle, okay, this material can sinter, or you can say melt very fast. Okay, so even below its normal melting point, the nanomaterial can undergo melting. Are very important and very relevant to the physicist, that is optical properties. Okay, what is optical property, how it behavior behavior with the different kind of radiation, all of you know very well. I'm just taking the concept which actually emerging today nowadays, the concept of HOMO and LUMO. Okay, LUMO band gap. Okay, band gap is also known to you. What is HOMO is highly occupied molecular orbitals, and LUMO is low unoccupied molecular orbitals. Now the actually the band gap which physicists are referring is the outcome of this HOMO and LUMO. Okay, this LUMO, okay, stand as your you can say valence band, and your HOMO will stand as conduction band. Okay, and the band gap between these, okay, what you are calling, okay, valence band and conduction band, is actually the band gap between this HOMO and LUMO. This HOMO and LUMO is highly applicable concepts when we are dealing with the quantum confinement, or when we deal with the okay, pseudo atoms. Okay, when we are considering nanoparticle as pseudo atom, we can rightly apply this concept of HOMO and LUMO to that particular nanoparticles as well. And because of this band gap, there is change in the band gap. Rather, as you decrease the size, the band gap increases. Okay, and because of this increase in the band gap, okay, there is blue shift. I think so everybody knows blue shift means, okay, the energy okay is required to the okay jump the electron will be more. Okay, so if you are requiring more energy, actually the wavelength decreases, and that's why we are calling it as a blue shift. Okay, and nanoparticle color changes in spectra due to surface plasmons resonance. Okay, this resonance actually, okay, you might have studied the chemistry. Resonance is something which is very, very important. Resonance means just like your metallic bonding. Okay, how in metallic bonding the electrons are basically, though it is belongs to one atom, but when we are considering the entire metal, this one electron, okay, okay, loses its connection. One electron loses its connection with the atom, and that electron now becomes the available to the entire matrix of the metal. Okay, so there is pool of electron which is available for conduction of this current or resistance, whatever it is. Okay, so similarly, okay, these okay plasmons are formed at the surface. Now just look at this. What happens? Why there is decrease in the melting point? As I told you, okay, these nanoparticles are having, okay, this upper surface, okay, which is not okay coordinate, and only the lower surface is coordinated. And because of that, these surface atoms, okay, you can see here, the surface atoms, okay, are pull inward. Okay, so there is inward shift, and because of that, the distance between two bulk atoms is larger than the distance between the surface atom and the bulk atom. Okay, so because of this, the surface atoms and bulk atoms, okay, are very close, and it can, okay, easily melt, and that is how it helps in sintering out the material. Okay, and the same thing is okay outlined in this one. You can see the scale is down. Okay, okay, downscale means the surface molecules are very near to the bulk material. Okay, the same thing is showing here. Okay, the same thing is expressed in different aspect. So in short, you can say because of increased surface energy, there is substantial decrease in the melting point. I'm taking the example. Okay, you take tungsten. Okay, everybody knows this material was present in the bulb. Okay, this tungsten is having actual melting point around 3000 degrees Celsius. But if you make a tungsten nanoparticle, it can sinter around 700 to 800 degrees Celsius. Okay, so this is the beauty of nanoscience nanoparticle. So there is substantial decrease in the melting point. Okay, now very pet for the physicist is optical property. I think so. Those who are doing luminescence, phosphorescence, okay, okay, they are very much concerned with this. You can have the look from the right to left. Okay, the right quantum dot, okay, is having the particle size of 650 nanometer, and the lowest one, okay, the green one is 510 nanometer. Okay, these quantum dots with decreasing size, you can see the which was having the higher size, okay, is showing you, okay, red one, and the one which is having 510 nanometer is showing green one. Okay, so if you are decreasing size again, you may get the blue color as well. So that is what the blue shift. Now here it is because of okay, there is okay, increased band gap. Okay, the band gap is increased, and that's why the amount of energy to jump now from valence to conduction band will be more, and that's why we are getting blue shift. Now you can see the very exhibition of this nanomaterial, okay, in the form of, you can say, okay, gold particles. Okay. You can see how these, okay, particles, gold particle, this is basically the display where even the shape of the nanoparticle matters in case of okay, optical properties of the material. Okay, you can see the different. Okay, I'm getting my voice.
Yes, sir. Yes, sir.
Okay.
Yes.
Yes, sir.
So here you can see, okay, how much time, okay, I'm having still.
Sir, 15 minutes, sir.
Okay, thank you very much, sir. So you can see here how the particle shape also matters in optical properties of the material. Okay, so this is very nice display. Okay, where you can have even the different shapes of the material giving different optical properties. And here, in continuation to the physical properties, this, okay, nanomaterial are extremely hard. Okay, they are having a very high tensile strength, and it is because of probably the reason that these particles are having zero defect. Okay, you can if I'm going little thermodynamics, the entropy of the system decreases substantially when you are going to nanoscale, and because of decreased entropy, there is a perfect orderness. Okay, and because of that, the defect in the particular material is reduced substantially, and because of that, there is increased mechanical strength. The same kind of material is spread in three-dimensional array, and because of that, there is extreme mechanical strength. Then electrical conductivity also decreases, okay, with reduced dimension. Now here, just I want to point out that many scientists, okay, who are working on this particular electrical conductivity, or okay, they are defying, they are trying to defy the Ohm's law. Okay, but there are many reviews, research articles which are also in favor of Ohm's law. They are saying that Ohm's law become robust. Okay, it is become more relevant when you are going to nanoscale. Okay, because Ohm's law, V is equals to IR, everybody knows that. Now the reason behind, okay, why the Ohm's law is a little irrelevant, or okay, some scientists were saying that it is not relevant, but it is because of decreased resistance. As you decreasing the particle size, there is decreased resistance, and because of decreased resistance, a time will come when you will have a superconductor material, okay, without resistance, zero resistance. Okay, so it doesn't means that Ohm's law is not applicable. Okay, then magnetic property, as I told you, nowadays to prepare super magnet and all that is very, very become easy. You can carry out the supermagnetism even at ambient conditions of temperature and pressure. It is all because of the increased surface energy. And self-purification and self-perfection, it is in harmony to what I said earlier, that it is having almost zero impurities. There is no defect, or there is no dislocation, no point defect, no plane defect. And because of that, the material becomes very hard and it has very high mechanical strength. And that also leads to a chemical stability. And very important, I'm going to come across this last one, that is this scale is comparable to biological structures. I think so. I'm having just 15 minutes, so you can just look at. There is also comparison. There is some kind of hypothesis that you can spread a fiber, nanofiber, from Earth to Moon directly, so that we can have a lift from Earth to Moon. That is something very interesting. But yes, it can be possible. Suppose you are having a high strength material made up of this nanomaterial. So we can have a lift from Earth to Moon directly made up of this nanomaterial, because of this mechanical strength. And probably it is due to two reasons, as I told you. Lower number of defects, and secondly, the fewer surface defects. What we are very important, that we should not have defect at the surface, because nanomaterial is basically depend on how the surface is. Again, this is mechanical properties. I'm just keeping out. This is also mechanical property. Now come to electrical property, which I left in between. As I told you, there is a expectation of increased conductivity, and then this basically due to surface scattering, change in electronic structure. Ballistic conduction means there is high amount of conductivity. Then discrete charging, tunneling conduction. Tunneling conduction means without resistance. If there is conduction of you can say, then you can say that is tunneling conduction. And what is the effect of microstructural effect? This is something requires more insight. I'm not going into that detail. And yes, now this is something again an important when you are preparing nanomaterial. What should be the size? And so far we have dealt only with the size, but as I somewhere mentioned, even the shape is important. Whether it is sphere, rod, or platelets, or it is the zero dimension. Then the composition of the chemical is also important in getting the particular size and shape. Then the crystal structure, whether it is BCC, FCC, depend on the number of surface atoms. We do calculate the number of atoms in FCC or BCC. So actually it really matters. Then the surface ligand or capping agent. This is capping agent. Many physicists, they are using some proteins or amino acid as capping agent. It is because of biocompatibility of that and the medium in which they are dispersed. Means in which material they are. What solvent we are using for the preparation of that. This is again a correlation between size and melting point. We already have done that. Then this is just I want to say a few words about this structural magic number. I already mentioned about pseudo atoms, which is a nanoparticle. It is known as pseudo atom because it is aggregate of few atoms. Now, how many atoms should be there? So scientists are working on that how many minimum atoms or how many minimum molecules should come together to get a nanoparticle or to get a change in the behavioral properties. So they are calling it as structural magic number. So how many minimum atoms or molecules should come together to give the properties which are really different from atom as well as bulk material. And these are the deviation from ideal crystals. Actually, nanoparticles are close to ideal crystal. Here, this is just a correlation. Just look at this number of shells. This is what important to understand. Number of shells, as we are increasing the number of shells around an atom. Number of shells means suppose you are taken one atom. How many other atoms can be around that? So maximum 12 atoms can be around that. Okay, so total you can have 13 atoms. You can just imagine one atom, around that in hexagon, around you will have 6 atoms, above you can have 3 atoms, below you can have 3 atoms. So that is how 12 atoms can be around one single atom. That is what coordination number. Okay, and taken together this 1 and 12 around, okay, you will have 13 atoms in a shell. Okay, and that is the minimum size which is giving you maximum surface atoms. Okay, so you can have 92% surface atom when you are having just a single shell which consists of 13 atoms. So this is something way towards magic structural numbers. Okay, so those who are going to do research, okay, these things is very, very important, that how many minimum atoms should come together to form a particle. Again, this is, I think so, everybody knows. What if we are cutting down the, okay, this is the just display of the carbon. Carbon is present in everywhere. I just want to highlight this graphene. Okay, the graphene is a very, you can say, novel material which is having zero resistance. You can have a conduction of electron at the speed of light in graphene. Okay, this is something very, very unimaginable, that electron can have a speed of okay, light. Okay, so this is possible in case of graphene, where the resistance is zero. And today graphene preparation, it becomes very, very easy. Now I also wants to owe my, okay, the credit of this presentation to these microscopes which are highly used in the material characterization of nanomaterial, which is SEM and TEM. Okay, same or TEM, what we call. Apart from that, there are other ways, XRDs and then okay, XAP, okay, even the FAM. Okay, there are many probes. Actually, as I told in the beginning, that this nanoscience was present already in the nature. What makes the difference is basically these probes or the characterization techniques. Okay, so because of advancement in the characterization technique, we are now having this advancement in nanotechnology. And this is the last one slide which I want to project before you. The young researcher, young students can look at this particular aspect of nanoscience and technology, which is still in the infancy stage. Okay, it is not yet developed, because physicists mostly concerned on the solids or materials which are used in electronics. Okay, chemists, they are doing their chemical job, but how it is compatible to the nature, actually, because nature display nanoparticles in vivid manner. So we just have to think about that. So here I have written colloidal nanoparticles. Okay, now this is you get some material about the colloidal nanoparticle, I don't doubt, but just my concern, it is only up to metal and metalloids. Okay, it is not has gone to other levels of nanoparticles. So we want to just discuss that this colloidal nanoparticles dimension is again 1 micrometer to 1 nanometer. So it is very close to nanoparticle. Then it also changes the property at colloidal dimension. How we are talking about nanoparticle, they are having different behavior when it reaches to nanoscale. Similarly, if a particle achieves a colloidal dimension, which I told 1 micrometer to 1 nanometer, then there is a lot of changes in the properties of this material. So that is very similar to nanoparticle. Then how this, which properties are changing? So mostly electrical and surface properties are changing. Then it is, yes, it is biocompatible, highly biocompatible. Okay, you just go throughout your morning, okay, throughout your entire day routine, you will find that you are coming across the paste, you are coming across soap, you are coming across okay, milk. All these are of colloidal dimension. Okay, what you are calling sole and gel are nothing but these are colloidal. There are a number of applications which are biocompatible. And okay, there, as I told you, there is a lot of research on nanoparticle and colloidal nanoparticle is going on, but still there is okay, the avenues are available in biocompatible colloidal nanoparticles. Okay, which are made up of, you can made up, okay, you can have a colloidal dimension or nanoparticle made up of enzymes. You can have nanoparticle made up of certain surfactants. Okay, you can have with polymers also. Okay, so there are a lot of avenues which are available, and the study of this colloidal nanoparticle can physicists can do very easily, because you know scattering effect, okay, you know Brownian movement, Tyndall effect, okay, all these are done by physicists. So you also can have avenues in this colloidal nanoparticles. So with this, I think so. I would have to stop here. This is the just takeaway message for all my dear students and my teacher colleagues, that service to science is a service to humanity. I can claim this particular statement because the social service which is done by the social activists, social workers, more than that social service we science are doing to the humanity. Okay, my dear sisters might be sitting in this conference. I would just like to remember the days when they were cooking, okay, the home food on some kind of woods and charcoals and all that. Okay, nowadays you just have to do that. Okay, you have to just lit up the CNG gas and okay, you can cook the food. You are having a pressure cooker, you are having a washing machine, okay, you are having okay electronics. Okay, so who has brought this? It is the science which is okay bringing this in the service of humanity. So my dear student, we should take the privilege that being a science student, okay, we should learn science, we should apply science, we should make aware about this science to the entire society, so that because this in true sense this science can be in the service to humanity. I must thank to Dr. Rahulkar sir, Dr. Wasnik sir, Dr. Yankar madam for giving me this nice opportunity. Okay, I have a different connection with the Vidya Bharati. Kishore Rahulkar sir might be known well, Wasnik sir might be well known. Okay, so I have due respect with the teachers and students and management of this college. Thank you very much, sir.
Thank you, Zade sir. Very nice and wonderful lecture.
Thank you very much, sir.
Okay, sir. Any questions from audience? Is there any questions from audience? Or if you have any questions,
Rahulkar sir, student might have put in the chat box. Okay,
yes,
you
yes.
can just go through that. We can take two, three questions because other speaker is also awaiting.
Yes, sir. Yes, sir. Those who want to ask questions, you can put in chat box. Okay, we continue for next guest, next speaker.
Okay.
Now, thank you, sir. Thank you, Zade sir.
Thank you, sir.
Now I request Professor Kushalyam Mude sir, my best friend, to deliver lecture on application of nanomaterials. Please, Kushal sir.
Yes, thank you very much, Dr. Raurkar. I express my sincere thanks to Vidya Bharati College, first of all, management of Vidya Bharati College, principal of the department, Dr. Wasnik sir, all staff of the physics department. Am I audible? Kishore
Yes.
sir?
Yes,
Am
sir.
I audible? Okay.
Yes.
I express my sincere thanks, first of all, to management of Vidya Bharati Mahavidyalaya Amravati. Also, I express my thanks to head of the department, Dr. Wasnik sir, rest of the colleagues, Dr. Raurkar, Dr. Lamdade sir, and rest of the colleagues. Okay, very long association with the Vidya Bharati College, even though we are in the Mumbai, but basically our native is from the Vidarbha. So very nice time to share with you all students, friends. So I am starting my lecture now. I am sharing the screen. So please bear 25 to 30 minutes with me. Just now, as Professor Ramesh Zade sir explain you the things about nanoparticles, I am continuing the same topic, but application part of it. Okay.
Yes.
Application part of it I am taking. This is about application of the nanomaterials in national webinar organized by this Department of Physics, Vidya Bharati Mahavidyalaya. The basics of this, whenever we are talking about any material, definitely there is a application part is there. Okay, Now, when we are talking about, so definitely there is a size, its length, its dimension, all these factors are there. Okay. Now, resource person already explain you about the properties and its basic things about the nanoparticles. So I am starting my application part of the nanoparticle. But before going to the application part, I want to share a little bit about the two renowned personalities. One is the international, both are internationally recognized. This is Richard Feynman, and another is Dr. CNR Rao. This is the Bharat Ratna, Dr. CNR Rao, Professor CNR Rao. Okay, because when we are talking about the nanotechnology, nanoscience, nanoparticle, these names are internationally recognized. See, on the YouTube or the Google, you will get the every information. But from that pool, what we have to take, see, lot of things are there. This is
Yeah.
all dishes are there, but which thing we have to select, that is very important, because we can't eat everything, otherwise there is a problem in the digestion. The same thing is there. Extracting is a very important thing, and what is the genuine source. So you are enough fortunate enough to have the very active faculties in the Vidya Bharati Mahavidyalaya, because they generally ask to speakers to conduct the lectures on the various topics. So definitely students get benefited because of such a webinar and seminar organized by the college. Okay, so when we are talking about these online resources, definitely we have to think about which are the genuine thing and which are the main contributors of this field. So when we are talking about the contributors of this field, so Richard Feynman gave a talk in the year 1959, which many years later inspired the conceptual foundation of nanotechnology. This is the very young man that time. Again, after 20 to 30 years, he delivered the talk on that. I think Professor Dhadesar already covered the Feynman part in that previous slides. So what Feynman clarified the topic, there is a plenty of room. See, basic concepts of this, what the Feynman contribution in that, everyone knows. But whenever we're talking about any topic, who is the main contributor of this worldwide is Richard Feynman. So salute to this great man in our scientific community. And second is this great man, Bharat Ratna, Professor CNR Rao. Students, friend, I want to share one thing with you. I think in most of us have know about it. India's first nanotechnology magazine. See, if you look at this digital era now, now is a 2020, the first magazine on nanotechnology that float in the year 2009. That float in the year 2009, meaning India's first nanotechnology magazine. Now, if you look at this picture, this is the first magazine in the nanotechnology. Means we are in the teenage now. In India, we are in the teenage now. Hardly 10 years. Means in the last decade, this year, 2009 to 2020, or just you can say decade means 2010 to 2020. In last 10 years, very little amount of work. This research work is there in the nanotechnology field, and there is a lot of scope in this field. Okay, as far as future research is concerned. Okay, now this is the courtesy of the nanowork news. I share this image with giving by giving the due credits to this nanowork news. And see, there was one mission by government of India to invest the substantial amount of money for research and development in nanoscience and nanotechnology, and government agreed to give the 1,000 crore as a nano mission. Students, see, in the year 2009, government started to think on this, and in a 10, 11 years, everywhere, means if you look at from the means north part, south part, east or west, or from Kashmir to Kanyakumari, in all downtrodden colleges or the urban colleges, everywhere this nano world is very famous now, and students are thinking about it, nanoscience and nanotechnology as application part, its fundamental parts from the school level. Okay, so this is the government activeness regarding awareness of this nano field in the year 2009. So this, please, I am giving the due credit to this great people, Richard Feynman, and as far as our country is concerned, this Professor C.N.R. Rao. Now, we are going to the next. This is a cover story feature is given here. Fellow and Scientific Advisory Council of India's Prime Minister and National Research Professor in the Jawaharlal Nehru Center for Advanced Scientific Research. Now, see why I am going to share this thing with you, students. I see lot of information we are you will get Google and YouTube and all, but see who is the main contributor. Where we'll get the genuine information. See all 1500 research papers and 41 books of this CNR Rao. Some of this is related to the another chemistry part, but some are the research papers and books are dedicated to this nanoscience and nanotechnology. So you can refer this. I'm sharing this for the sharing this information with you because you can visit the site just to simply type the CNR Rao research papers and you will get all these books and these research papers, full-length papers on the digital platform. Okay. Now, as previous lecture, I hope you understood the concept of this size. When we are talking about the nano, see the nano, this is not the new thing for you. जब हम सोचते हैं कि ये साइज छोटा है, चलो नैनो मीन्स छोटा साइज है, बट मराठीत आपण म्हणतो की एकदम छोटा छोटा, गुजरातीमध्ये नानू छे नानू, मुझे लगता है वो नानू भी तो नैनो से ही आया होगा. तो ऐसा नहीं है कि मिडिल एज में या प्रायर टू दिस मॉडर्न एज की नैनो साइंस के बारे में, नैनो टेक्नोलॉजी के बारे में वर्ल्ड में किसी को कुछ पता नहीं था. ऐसा नहीं हो सकता है क्योंकि ये सब चीजें पहले भी थी, बट बिकॉज ऑफ दिस communication and record keeping that was not there. As you know, the discovery of an atom, credit goes to Dalton, but you know महर्षि कनद ने बोला था कि अणु करके है 600 BC में, but we can't say कि atom discovered by the Kanad because scientific records there on the name of the Dalton. See, these are the size, clusters, nanocrystals, and the quantum dots 1 to 10 nanometer. When you are talking about the nanoparticles, 100 nanometer is there. Means 10 raised to minus 9 and this 10 raised to 2, it come across 10 raised to minus 7. Means this is micros level is there 10 raised to minus 6 and it's a 10 raised to minus 9. You see what happened to the nano, because when we grind anything to the nano level, it gives some exotic properties. That's the physical properties, chemical properties, and the previous speaker, Professor Ramesh Dhade, cover the things related to that. What happened exactly? Now I'm giving one simple example here about our eatable things. For example, you have the chopping of the onions. थोडं मराठी आणि इंग्लिश आणि हिंदीचं कॉम्बिनेशन करतोय मी. जसं आपण एखाद्या बुफेमध्ये किंवा आपण जेवायला गेलो किंवा आपण घर में अगर किसी खाना बनाया और चॉपिंग किया, चॉपिंग ऑफ टोमेटोज एंड चॉपिंग ऑफ दिस थिंग ओनियंस. ओके, if you chop it properly, there are the standard chopper now to grind it properly, to chop it properly, and you see the difference. If you grind it, if you chop it properly, you will find the difference in a taste. This is like a material science mixture. For example, constituent is same. For example, preparation of the tea, constituent is same, tea powder, sugar, ginger, and all things are there, but taste is different from hotel to hotel, from home to home, and that whoever is preparing, constituent is same, but that depends on all the proportion and how they are taking. So here it is size matter. Even if you look at the atta, and when you are preparing the chapati, if atta is not grind properly, then you will find the difference in the taste. Okay, so that size matter. Means student, when we reduce the size to this 1 to 100 nanometer, for example, any material from the periodic table, if you take, lot of change in the property, means what? We are getting the good result. Okay, we are not going to discuss in detail about the result because there is a lot of change in the physical and chemical properties. That's a positive change, we can say. But see, this is the nanowires and nanotubes. These are the very current topics as far as research is concerned in the metal, semiconductor oxides, sulfides, nitrides. Then this is carbon, including fluorines layer and chalcogenides. Now, see, we are talking about the nano as I shared one slide with you of the CNR Rao, Professor CNR Rao, that first magazine in India published in the year 2009. बस इसका मतलब ऐसा है कि पहले कुछ भी नहीं था नैनो के बारे में. If you look at the pre-modern era, this is the middle-age stained glass, medieval stained glass, what we can call as a middle-age stained glass windows, are an example of how nanotechnology was used in the pre-modern era. Again, I am sharing the courtesy to the nano bayonet. This is the figure here. Okay, you can enlarge it. That already I shared this PowerPoint with the Dr. Raulkar sir. He means that is available on the net also. Okay, so see, look at this glass. Even 100 years, 200 years, it will not affect the original structure. Means that durability is there. That's the beauty of the nano. I hope many of you visited Mumbai and look at the Mumbai University building. That Mumbai University building, adjacent to that, there is a convocation hall. That's called the Rajabai Tower actually, Mumbai University building. And there is adjacent to that, there is a convocation hall. If you look at the glass paintings, that's a very old. Now Mumbai University established in the year 1857. Okay, if you look at the structure of the glass, that's a very fine. This is a very brilliant look that glass have. So what is that in the pre-modern era that was there? See, we are not aware. That's our fault. But it is not the thinking that was not there. But definitely in research, we are searching, we are researching, researching, and we'll get update ourselves. Okay, means this is the case of the pre-modern era. I want to share with you, and I already shared this thing. Now, another important thing as far as application is concerned is the purification of the water or the filtration of the water. I am giving the courtesy to the Elsewhere. This is a very standard publisher worldwide, and journal is there, Thin Solid Film, volume 517, and this is again in the year 2009. You know, the reverse osmosis, simple water filtration, and you know, in Vidarbha region or in any region of our country, there are some downtrodden part, some remote part. In there, no one use this water purification, this filtration process, but they are capable to digest that food or whatever the contaminated water. They are able to overcome that. Means they are not get affected because of that. But in city like Mumbai or in the metro city, everyone used to have the water purifiers, because that pipeline is coming from that dam to the corporation, then corporation to that. During that entire process, there are chances of the contamination. Then, as far as this, in view of this COVID-19 pandemic, all of you aware about this this coronavirus, novel coronavirus. See, coronavirus was there in the 12th standard book, and that was SARS related type that was there. But this is the new thing, and this is affecting the lungs, and no one was aware. Entire world health organization was not aware how it spread. बीच में आया कि हवा से फैलता है, नहीं फिर हैंडशेक करने से फैलता है, मास्क यूज करने से कुछ फायदा नहीं है. बिकॉज ये सब क्यों ऐसे assumption चल रहे थे सब, दिस आर द प्रेडिक्शन, क्योंकि किसी को पता ही नहीं था कि हाउ इट स्प्रेड. बिकॉज स्प्रेड के बारे में अगर पता चाहिए, कुछ पता करना है, तो अपने को पता चाहिए उसकी साइज क्या है. तो शुरू में ऐसे आपने भी न्यूज में देखा होगा या WHO ने भी बोला होगा कि इसके साइज के बारे में, उसकी साइज क्या है कोरोना वायरस की, बिकॉज दिस इज नॉट विजिबल. तो किसी का अजम्पशन था कि माइक्रो साइज में है, किसी का अजम्पशन था कि नैनो साइज में है, फिर सरफेस पे वो रह सकता है या नहीं रह सकता है, फिर फ्लो कैसे ट्रांसमिट होता है. तो दिस आर द मेनी थिंग्स रिलेटेड टू दैट. तो फर्स्ट ऑफ ऑल वी हैव टू स्टडी द साइज ऑफ इट, दैट इज द इम्पोर्टेंट हियर. Okay, water is one of the essential enablers of life on earth, beginning with the origin of the earliest form of life in sea water. See, there is a lot of water in the sea. If you look at the coastal line, if you look at the Mumbai, there is Arabian Sea, but that water is not, we can't use that water because that whatever the salt percentage, all of you know. But can you purify it at a large scale? No, that is not possible. Then for human civilization, whatever the noble traits have been similarly associated with the prosperity of the human civilization. See, जैसे जैसे civilization होते गया, prominent use of jewelry and all related to this. Okay, related to this electrochemical potential, contraction, molecular orbital theory. So in this process, there is a role of nano. I am not going to detail, but like simply purification. See, पहले तो अपने अभी भी in the remote area or in the downtrodden part, अपन तो एक ऐसा जैसे कपड़ा है कॉटन का, एज अ फिल्टर करके वही यूज करते हैं. तो जो भी जैसे विजिबल चीजें रहती है, वो तो अपने आप वहां से अपन सेपरेट आउट कर देते. बट जो ऑलरेडी वो मिसिबल है, वाटर में ऑलरेडी कॉन्टेमिनेटेड हो गया, तो उसको कैसे करने का, देर आर द different technique, UV technique, then reverse osmosis and all. So this nano has a great role in that purification process also. Okay. Now, see, this is related to that nanoscale, nanomaterials, and whatever the contaminants that have endanger the quality of the drinking water. Now, this the overview of the 200 years area of our drinking water purification is presented. Again, that depend. अभी कुछ तो अपन रूरल पार्ट बहता पानी है नदी का, वही पी जाते हैं अपन, तो भी कुछ नहीं होता है. लेकिन जो ऑलरेडी आरओ वाटर पी रहे, रिवर्स ऑस्मोसिस हुआ, ऑलरेडी बिस्लेरी वाटर पी रहे, बिस्लेरी मींस मिनरल वाटर पी रहे, अगर एक दिन वो आदमी अगर बहती नदी का पानी पी रहे, गांव के लोग तो वही पी रहे, अगर दूसरा कोई आदमी जिसको रिवर्स ऑस्मोसिस हुआ या फिल्टर वाटर, मिनरल वाटर पी रहा है, वो अगर एक दिन पीता है तो उसकी बॉडी एक्सेप्ट नहीं करेगी, उसको कुछ ना कुछ अफेक्ट कर देगी. ठीक है. तो दीज आर वैरी फ्रॉम इंडिविजुअल टू इंडिविजुअल, बट contaminants removal that can be possible by use of this nanoscience application or the nanoparticle application. Now, there is a simple diagram given in that paper. Whatever the materials they use and what filtration process they use, they have. This is for your reference. This photograph I am sharing with you. Okay. Now, there are the various fields. Non a single field now, not using nano. Will not find any field in the world now. Everywhere there is uses of the nano. This is a simply flash of this automotive industry, chemical industry, in the field of engineering, electronic industry, construction, medicine. See, this is the simply flash of it. Okay, what this in automotive industry, lightweight construction, painting, okay, tires, sensors, coating for windscreen and car bodies. In automotive industry, there are a lot of uses of the nanoparticles are there. Okay. In chemical industry, fillers for a paint system. You know, जैसे अभी बहुत सारे पेंट अवेलेबल होते हैं, या अभी अपन क्लॉथ्स लेते हैं तो कुछ ब्रांड है, तो ब्रांडेड प्राइस बहुत ज्यादा है एज एज इफ यू कंपेयर दिस विद द लोकल. उसमें क्वालिटी क्या है, तो क्वालिटी एंड कॉस्ट इफेक्टिव हो गया वो. ठीक है ना. तो जैसे 100 रुपए में भी शर्ट मिल रहा है और 2000 रुपए में भी शर्ट मिल रहा है, तो व्हाट फीलिंग विल गेट, वट एवर द कॉटन एंड ऑल material used in that case, that's a very fine form. Okay, so that can improve the performance there as far as this nanoparticle is concerned. So just these are the field in front of you: the medicine, engineering, construction, electronic industry. Okay, this is the simple flash of this. Textile, food and drinks, household, energy, cosmetics, sports, everywhere that is used. So as far as today's situation is concerned, everyone is affected worldwide by this coronavirus, and still we are lagging in the field of medicine. So can this nanotechnology in future play important role in view of this COVID-19 pandemic? If such situation occurs after 100 years or after 200 years, is the science and technology will be useful to overcome that point? That's why thinking and studying in this field is very important. So at nano level, materials begin to demonstrate entirely new chemical and physical property, some part of it covered by the previous resource person. Materials can be stronger. Materials can be stronger, lighter, and highly soluble, reducing of a melting point. Okay. Now, this is about, again, by manipulating the arrangement of atom, nanotechnology may be able to create many new materials and devices. See, this is, or we call generally in terms of the physics, optical engineering, that band gap engineering. We can reach to the device. See, research is there at all colleges, university, National Science Laboratory, Indian Institute of Science, CSIR laboratories. It doesn't mean कि कॉलेज के एक ही अपना तालुका प्लेस पे कॉलेज है, डिस्ट्रिक्ट प्लेस पे कॉलेज है, वहां पे रिसर्च नहीं होता है. सब जगह रिसर्च होता है. ऐसे भी कुछ नोबेल प्राइज आए हैं जो एकदम ही रूरल पार्ट में हुए. दैट्स अ थॉट प्रोसेस इज वेरी इंपॉर्टेंट. ओके, डेफिनेटली इंफ्रास्ट्रक्चर प्लेज एन इंपॉर्टेंट रोल, नो डाउट इन दैट. Okay, but no one can stop you from the research. That requires a thought process. Okay, now Nanotechnology has a several application on many fields such as medicine, electronics, energy production, water processing. That I cover a little bit. Energy production. Now, students, as a students of electronics, all of you know, initially we used to have the tungsten filament lamp. You know, there is a tungsten filament, and you know the high melting point, 3310 degrees Celsius. But that was a power consuming. After some times, before 10 to 15 years, we used to have CFL lamps. That's what बिफोर दैट आई कैन से एफटीएल दैट्स द फ्लोरेसेंट ट्यूब लाइट तो फ्लोरेसेंट ट्यूब लाइट अपने को पढ़ाई करने में भी अच्छा प्लीजेंट फील देता था वो व्हाइट लाइट है वो येलो लाइट में थोड़ा इरिटेशन भी ज्यादा रहता था पावर सेविंग हो गया है फ्लोरेसेंट ट्यूब लाइट आफ्टर फ्लोरेसेंट ट्यूब लाइट अगेन देयर इज अ दिस थिंग व्हाट वी कॉल्ड CFL compact fluorescent lamp okay again that is power saving visibility is more as compared to power consumption and all with reference to tungsten filament this fluorescent tube light but nowadays we are using the LED that's a light emitting diode see the day by day decade by decade lot of things are happening in the field of research size has been reducing and durability its effectivity is going on increasing year by year day by day now in the medical application of nanotechnology it is defined as the repair construction and control of a human biological system using devices built upon nanotechnology standards see as a physicist we can enter in the chemistry we can enter in the life science also okay so the role of physics is very important it has a very broad spectrum of the physics this is very useful this is useful in the mathematics also even though this part is of the biological sciences or we can say the life sciences but principles applications part is very much related with the physics now you know the ophthalmology field in the many operation techniques okay they use the nano application nanomedicine part in the drug delivery are concerned see we used to have the milligram doses you know milligram जैसे अपन कोई भी अपन प्रिस्क्रिप्शन अगर देते हैं डॉक्टर तो उसमें वो मेडिसिन का नाम दिया होता है and if you look at the that specification of the tablets or the syrups tablets में जो भी है तो milligram है ना पावर जिसको बोलते हैं कितने पावर का मेडिसिन है so that is what the nano structural materials there are the specially engineered enzymes and many other products of biotechnology will be very useful in the nature see this biotechnology is also the very useful field related to nanotechnology day by day now in the genetically modified crops you know the bt cotton in the vidarbha region many cotton belts are there so bt is not harmful for the environment but there are some mites related to that so scientists are working on it see we not believe in the mites okay some mites will be there but we need to as a student of science or as a human being we need to clarify we need to talk about the experimental evidences by the respective science laboratories okay this nanomedicine that will allow doctors to approach the human body at the cellular and molecular level see the molecular level you know the size of an atom that is in the order of 10 raised to minus 10 and nano is dealing with the 10 raised to minus 9 you know the nucleus as a student of physics you know the atomic structure nucleus structure introduction to nucleus already talking about the 10 raised to minus 14 10 raised to minus 15 okay means this nano 10 raised to minus 9 this scale is not new for us but as from the concept of this Richard Feynman from 1959 and today is 2020 a lot of things happen in the field of this but there is a lot of scope in the future as far as the application of nano is concerned okay the next part is here the nano medicine is a huge industry and I'm not going to share the whatever the turnover in this field that's definitely that's a commercial part and how much world is spending in that and as far as this textile industry is concerned whenever there is a bt cotton introduced so that time textile industry that turnover is increased definitely so this technology is helpful for the economy also technology is useful for the economy also okay this nanomedicine part nanotechnology can be used in the many fields of the medicine pharmacy visualization cancer there's diagnosis surgery there are fields are there okay then we go to the next part now. This here, it can help giving suspension as IV injections. You know, this IV injections, all of you aware about it. When we are talking about the nano pharmacy, okay. Now see, there is a concept of the generic medicine also. कुछ लोगों का ऐसा मानना है कि अपन अगर टेक्नोलॉजी और साइंस एंड टेक्नोलॉजी को अगर बढ़ावा देंगे तो अपनी जो पुरानी चीजें हैं, जो कि गांव की जो मिट्टी की सुगंध जिसको बोलते हैं, वो चीजें अपने आप लुप्त हो जाएंगी.
Rahulkar sir, there is some issue, I think.
Net problem, I think.
Okay, from the side of research person.
Yes. I think, yes, yes. I think he's joining now. Again, he's joining now. Yes, yes. Sorry.
Sorry for the inconvenience of this because of the network issue. खूप जास्त गॅप झाली का? खूप आधी हे झालं? 2 मिनिटं ना? आता जस्ट आउट झालो ना मी.
Yes, 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 sir.
हा किशोर सर.
Yes, sir. You
continue with the same.
Continue, sir. Continue, sir.
Yes, yes. हाँ तो as we are talking about that, as we when we are talking about this nano thing, the nano pharmacy. See, generic medicine has its own importance. Homeopathy has its own importance. Ayurveda has its own importance. India come up with the Ayush, you know, Ministry of Ayush. A for Ayurvedic, Y for Unani, U for Unani, okay, Y for Homeopathy. Initially, there was a fight between this thing, allopathy doctor and the homeopathy doctor and this Ayurveda doctor, है ना? So जैसे homeopathy कुछ science ही नहीं, the nanotechnology, there is a role of nanotechnology and this whatever the rings, that structure, IIT has a lot of applications are concerned. Okay, now we go to the next. As in continuation with this. Mostly unknown due to the difficulty in targeting specific organs in the body. Okay, see the targeting that foreign part of the very specific delivery now. Okay, there is a very specific delivery now, so that can be achieved. That can be achieved with the help of large gold nanoparticles were found to enter the kidneys. Now, a lot of problems related to this kidney stone and all available. These all are the application of this nano. Okay, nano cells can be targeted to bond the cancerous cells by conjugate. Okay, these are the things here. nanomedicine, that is irritating the area of the tumor with an infrared laser which passes through the flesh of the cancerous cells, and that is unharmful to the others. That is unharmful to the others. This is a photodynamic therapy in context of the chemotherapy, but that is again the many therapy are coming up as far as this how to overcome that cancer to unharm the rest of the cell. In the surgery part is also there. Okay, in the surgery part, that nanoparticles, cadmium, MSc students and all researchers are the students. Here I stop, and good luck to all my students, friends, for your bright academic future and healthy mind in pandemic. Stay safe, and please tune with your teachers. Please tune with the teachers in online platform. Okay, because teachers are not teaching you in the classroom, but all are connected with you all in an online platform, whether it's a Google Meet or the WebEx, and again at last, thanks to all, thanks to you all for your participation and interaction here. And if you want to, and special thanks to the management of Vidya Bharati Mahavidyalaya, Principal Madam, and all entire staff of the Physics Department.
Thank you, Mude sir.
Thank you once again. If you want to ask,
if anybody want to ask questions, can ask or put in chat box.
you can interact. You can interact. Don't mind to ask the questions. You can interact. You can interact through the
तो पूछ सकते हैं. Otherwise, you can
chat box. You can send questions to the Vasnik sir, Kishore Raudkar sir. You can interact. Or good researcher are
I think there is no
there in the Vidya Bharati principal, your previous principal, all are very student friendly and very stalwart.
Thank you, sir. So I think there is no question.
Definitely, your staff like Vidya Bharati College, and definitely many ex-students are there in the various fields in abroad, in the pharmaceuticals, and in IT sector also. In everywhere you will find the students of the
Thank you, sir. Thank you very much. I think there is
Vidya
no
Bharati. Many students.
I think there is no question, sir, from our audience. Thank you, sir, for your great enjoyable lecture on application of nano.
Okay.
Dr. R.M. Patil, sir, IQSC coordinator, though he is not feeling well, joined our meeting and grace our meeting. I pray God for speedy his recovery. Patil, sir.
Yes, sir.
Yes. Sir, would you like to speak few words?
Okay. Okay, sir.
Yes. I request Dr. Patil, sir, to address us.
Respected principal of the college, Dr. Yankar, the head department of physics, Dr. Vasnik, the entire team of Department of Physics, the respected both the speakers for this very useful webinar on nanoscience, nanotechnology, Dr. Ramesh Dhade and Dr. Kushal Mude from Mumbai. I welcome both the academicians for sharing their valuable views on nanoparticles, nanoscience, and nanotechnology. As a student of language and literature, I have heard this term nano when the car was launched. And from there itself, my general perception of nano word was something that is small in size. And really, This nanotechnology is not immediately though is connected with physics, but it has its relevance to each and every walk of life. As Professor Mude mentioned, that medical science and all branches of knowledge in natural sciences, nanoscience is playing a very vital role nowadays. A student of science, what used to be in the past, and a student of science in present context need to be upgraded because the world is rapidly changing. The variety of innovations and research which has completely altered the human life. And that's why these relevant branches of knowledge, they are playing very vital role in making human life comfortable on this planet Earth. I'm sure I was listening all the while both the lectures of these very well-versed physicists, but the American professor physicist, the Nobel laureate of 1955, if I'm not wrong, was awarded Nobel Prize for his extraordinary work in making good service of physics. That Professor Richard Feynman, who did good service of humanity. I'm sure these both the lectures, they definitely, one was the opening lecture that was discussing the basic concepts of nanoparticles and nanophysics and nanoscience, and Professor Kushal Mude cast light upon what is the application of it in our day-to-day life. A man like me who is directly not connected with science, if could sense something out of it, I'm damn sure that all teaching fraternity and especially the faculty belongs to physics, that they must have enjoyed these two dishes here delivered by Kushal Mude and Professor Zade. I extend my sincere thanks to them for being connected with us and sharing their important views. I am not feeling well, as Professor, my friend Dr. Raulkar mentioned it, but I am very speedily improving, and I am sure perhaps in a day or two I will be able to join my duties. So I extend my best wishes to all of you, and thank you, Professor Raulkar and Dr. Vasni, because I since last 1 month I am lying in my private chamber for around 30 days together. So this has really made me happy to have an interaction with you all. Thank you very much. Thank you, sir.
Sir, thank you very much, sir, for your blessing. Thank you, sir.
Thank you, sir. Thank you, sir. Take care.
Okay, okay, sir. Nice.
Yes.
No, I think Principal Madam joined the meeting. Now I request Honorable Principal Madam, Dr. P.S. Senkar Madam, to address us. Ashwin Chauhan sir phone. Okay, Madam is busy with another work. So we are at the last part of the program, that is vote of thanks. I call upon Mr. Rohit Butle to propose vote of thanks. Rohit Butle.
Good afternoon, one and all. I, Mr. Rohit Butle, here to propose vote of thanks on behalf of Physics Department, Vidya Bharati Mahavidyalaya, Amravati. I express my hearty sincere thanks to Honorable Shekhawat sir, Mrs. Manjari Shekhawat ma'am, Chairperson of James Vidya Bharati, Honorable Secretary Dr. Edi Chavan sir, Honorable Principal Dr. P.S. N.R. ma'am. I am very thankful to Dr. R.M. Patil sir, though they are not feeling well, but they have joined the webinar and graced the meeting for making the platform available and giving permission to conduct webinar on recent trends in nanosciences. I take this opportunity to express my gratitude and special thanks to eminent speaker, Professor Ramesh N. Dhade sir, Associate Professor, Department of Chemistry, Siddharth College of Arts, Science and Commerce, Mumbai, and Professor Kaushal M. Modi sir, Associate Professor, Department of Physics, Women's College, Andheri West, Mumbai, for your august presence as your esteemed resource persons and enlighten us by delivering lectures in this webinar. Your very presence imparted a rich academic dimension to the event, and your lecture on behavior of nanomaterials and applications of nanomaterials. We are intellectually stimulating and academically enriching feast of knowledge and wisdom for all of us. Thank you, sir, very much. Also, I express my thanks to our HOD, Professor T.S. Watnik sir, Professor R.B. Jodh sir, Professor G.D. Lamdade sir, Dr. K.B. Raulkar sir, Dr. A.O. Chavan sir, Mr. C.C. Jadhav sir, and Mr. Ashwin Meshram for having valuable contribution to this grand success of this webinar. I also express my sincere thanks to all participants for their esteemed presence, and also I am very thankful to all teaching and non-teaching staff of the department for their valuable support to this grand success of webinar. And with the permission of chair, this webinar is over. Thank you. Thank you, Dhade sir. Thank you, Kushal sir.
Thank you very much. Thank you, Rohit.
Thank you, sir. Thank you. Thank you, sir.
Thank you, Vasnik sir.
Sir, unmute. Sir, please unmute the mic.
Thank you, sir. Thank you, sir.
Sir, your mic is muted.
Thank you, Patil sir.
राऊळकर सर धन्यवाद.
धन्यवाद बोडके सर.
पाटील सर काळजी घ्या आणि मला वाटतं 1-2 दिवसात तुम्ही छान कॉलेजला मजा घेणार.
नाही मी याच्या झूमवर गेलो.
थँक्यू सर.
Thank you, sir.